Hey guys, hello everyone and welcome to the channel. So we are very near to the exam. You only have few days for the exam and I thought to share some videos where I'm going to discuss about most repeated topics or most important topics from inorganic chemistry, organic chemistry and physical chemistry. So that if you're preparing for the exam, you don't miss out these topics. Okay, so I thought of making these three videos and do let me know what are your thoughts on it. And I think this is gonna help you if you are, let's say, if you are preparing two of them. Let's say if you are preparing organic and inorganic in detail, and if you are planning to just leave physical chemistry or not study physical chemistry. So after watching these videos, probably you will like try to study some of the topic or try to practice some of these topics, because these are most repeated topics from where you will of course get a question in exam, like most of them. Okay, so these all topics which I have included, they all are based upon the previous years, and we expect questions from these topic in the upcoming exam as well. So here's the video where I'm going to talk about most repeated topics from inorganic chemistry, and if I'll get a good response on this video, I'll make for organic and physical chemistry as well. So do let me know in the comment section. So let's start with it. So we will start from the most important topic of inorganic chemistry, which is coordination chemistry. All right. Now in coordination chemistry, you know that the question, like the topic from where you will of course get a question, or you will like in most of the cases, if you will see previous 10 years, you will see that out of 10, 6 or 7 times you have got a question from John-Taylor distortion. So this is a very important topic. Now there are various different types of questions that can be asked from John-Taylor distortion. It's not only that they are going to ask that in which of the complexes you are going to experience, or you are going to find a complex with John-Taylor distortion. They can mold the question in another way. They can combine it with spectroscopy, and they can ask you about G parallel and G perpendicular concept. Then they can also combine it with the hybridization, and they can ask you that which of these molecule or which of these given complexes they have a proper geometry, which of them have a distorted geometry. So there again John-Taylor distortion comes in. So John-Taylor distortion is a topic which relates a lot many things, so you should be clear with this particular concept. It's a very important topic. Then comes Orgel diagram. Orgel diagram, again, it's one of the important topic, and from Orgel diagram some types of question which you will generally see is like ground state term, symbol of the transition metal, like from where the transition has started. So generally they ask that which, so if let's say if you are making a Orgel diagram for D2 complex, okay, so for that what is going to be the ground state term. So for D2, from where to where you are going to have that transition. Okay, so you should know that if it is octahedral complex, the transition will be from T2G to EG. So these type of questions are asked generally. Okay, then number of absorption band, how many absorption band you are going to get. In case of D3, you get more than one band, and then which band will have higher frequency, which has lower frequency. That comes in the transition frequency type of question. Sometimes numericals are also asked from Orgel diagram, where they might give you the transition frequency value in centimeter inverse, and they might ask you the crystal field stabilization energy. So these type of question you should be clear about. One more topic is there, that is Tanabe-Sugano diagram, but that topic has not been asked many times. But yeah, if the paper level will be difficult, if the question has to be asked from a difficult level, then they might skip Orgel diagram and ask Tanabe-Sugano diagram. So yeah. Then the next thing is color and spectra of the complex. Various time question has been asked based upon color and spectra of the complex, which of the which of the transitions are allowed and which are forbidden transitions. So they might ask a question like which of these complexes have color and which does not have color. So based upon that, whether the transition is allowed or not, whether the geometry is a symmetrical geometry or unsymmetrical geometry, based upon that we define the intensity of color, we define what type of color you are going to get. So yeah, that comes in color. And from spectra you get charge transfer spectra, like ligand to metal charge transfer, metal to ligand charge transfer, then ligand to ligand charge transfer, and intervalence charge transfer. So those charge transfer spectra also you should know about. This also comes under the color and spectra topic of coordination chemistry. Then comes isomerism. From isomerism you might get a 2-marker question. Generally 4-marker questions are not asked from isomerism, but yeah, you might be asked to find the number of geometrical isomers or optical isomers or stereo isomers. This is very basic. Okay, it's not difficult. This is something which you might have studied since your bachelor's, I would say. So yeah, you should be clear about isomerism as well. Then comes your magnetism. In magnetism, I have included transition metal and lanthanides both because magnetism is a topic which comes in both of these, and you should be able to find out the magnetic moment of the complex. You should be able to find out whether there will be some orbital contribution or not, whether you will be having spin only magnetic moment, what are the formula for that, and calculating the G value. Same goes for lanthanide. We have a like expanded formula for calculating the magnetic moment. So sometimes direct question has been asked to, a complex or a ion will be given to you and they will ask you to find out the magnetic moment of that. One more thing that you have to understand, that sometimes questions are asked in a different way. They just give an ion and they then ask the magnetic moment, and sometimes they give you the complex and then ask the magnetic moment. So when the complex is given, you have to consider the ligand effect also. That means you have to look that whether the ligand is a strong field ligand or not, and whether it is, applying the pairing of the electron is happening or not, and based upon that the electrons are going to be different in different orbitals, and that is going to change the things, that is going to make a paramagnetic molecule diamagnet. So basically you should be aware about questions related to magnetism, and these are easy questions, okay, they are not difficult. Then your electron transfer reactions, where you talk about, or we study about, inner and outer sphere mechanism. So yeah, this is again a question or a topic from where you might expect a 4-marker question. Generally they are asked in 4-marker question. So if you have to, give it in the form of marks, so isomerism is the only topic from where you will get a 2-marker question. Others are eligible to get 4-marker question. You can also get 2-marker from there, but yeah, most of them are 4-marker, like they carry 4-marker question. So if you are preparing coordination chemistry, make sure you don't miss out on these topics. Then comes organometallic compounds. This is again one of the important topic of inorganic chemistry. Inorganic chemistry, if you consider total inorganic chemistry as 100%, so coordination and organometallic themselves make around 60% of the syllabus, or 60 to 70% of the syllabus. They are big topics, highly important. They have application also in the research field. So once you complete, or once you qualify JRF, and once you go for research, these are the topics in which you will be probably doing you will be doing your research in. So yeah, that's why they are important for the exam perspective as well. They want to know more that whether you understand these concepts in detail or not. All right. So yeah, as I said, in organometallic compounds, you have to study isolable analogy. You have to study all the types of questions from 18 electron rule. And believe me, like organometallic compound questions, like 60-70% of the questions can be done easily if you know how to apply 18 electron rule, like without making mistakes. Okay, so there are two methods of applying 18 electron rule. One is neutral atom method, one is ionic method, okay, or ion charge method. So you should be aware about both of them or just one of them, so that you don't get confused in exam. But yeah, you should be able to do questions based upon 18 electron rule. Then a concept of carbene. So carbene and nitrene, they are in your syllabus. Generally we see more questions from carbene compared to nitrene. So whatever topics I am including, it does not mean that you will never get a question out of here, but I am just including those which has been asked multiple times, so that you don't miss out these topics. Okay. Then there is the concept of synergistic effect. You know that when a metal carbonyl is formed, and if you have more electron in the metal, what happens to the metal carbon bond and what happens to the carbon oxygen bond, how the electron of the vacant d orbital goes to the p orbital, and the sigma bond and pi bond electron sharing, how does it happens, how does the electron goes to the anti-bonding orbital, and how does it affect the bond order of carbonyl. So that's the synergistic effect. How does it changes upon application of upon increasing the oxidation state of the metal, upon changing the size of the metal, upon changing the ligand effect. So all these effects, how does they affect the synergistic effect, how does they affect the metal carbon bond length, and how does that affect carbon oxygen bond length in the metal carbonyls. That's what you study in synergistic effect, and you generally get a question from here. Okay. Then there is a concept of Wade's rule. I hope you all know about it. Wade's rule is for boranes and carboranes, to find out whether the given carborane or a given borane is closo, nido, or acono, clado, whatever it is. So you should be aware about how to apply Wade's rule. It's super simple, and you generally get a 2-marker question from here as well. Then comes your reaction mechanism. This is something from where you get a difficult question, or a question in a 4-marker, where they might give you a particular reaction and they might ask you what's happening in a particular step, or something in that way, where you study 4 of these reactions which are important. There are others also, but these 4 are important, like oxidative addition, reductive elimination, transmetallation, and beta hydride elimination. There is alpha hydrogen elimination or alpha hydride elimination as well. So those things are also there, but you should be aware about at least these four in detail. Then comes your trans effect. Based upon trans effect, there are various things like how a particular like square planar complex, how which ligand is gonna which is going to get dissociated from the complex first. That depends upon the trans effect, and various types of questions are asked, like the formation of cisplatin and related questions. So you should be aware about trans effect, the series of that. Sometimes direct question is asked, like which is the correct sequence of trans effect. Should be aware about the series of ions based upon their trans effect priority. All right, now let's go to the another topic, which is main group and chemical bonding. I have compiled both of them. See, main group is a big topic. It's a huge topic, and there are a lot of things to study from there. But the weightage, there is something called as effort to weightage thing. That means how much you have to study the topic and how much marks it is asked for an exam. I think that that is very imbalanced for main group element, because you have to study a lot of things, but the questions or the weightage of that topic is not, like, it does not justify the length of or the syllabus of main group. So that's why I have compiled both of them. I have just included few things. There are various other things which you have to study apart from them. So it starts from your VSEPR theory. So in VSEPR theory, you should know how to find out the shape and structure of the complexes or the molecules. And then there is a like hybridization, how to find out the hybridization. Then there comes a concept of bent rule also over here, like which decides the bond angle and all. So you should be aware about bent rule, because direct questions have been asked from there. Then how to calculate dipole moment. So these all things comes from the VSEPR theory. It's a very important concept. Generally, you expect a 2-marker question from here. Then comes your molecular orbital theory, in which HOMO-LUMO is being asked. So you should know how to find out the molecular orbital diagram of diatomic molecules, heteroatomic or homoatomic. For example, you should know how to form the molecular orbital diagram of O2. You should know how to find out the molecular orbital diagram of CN, okay, so, or CO2. So you should be aware about finding or forming these molecular orbital diagrams, and you should also know how to fill the electrons, so that if the question is asked that in which orbital the HOMO, or which orbital has HOMO or which has LUMO, you should know how to do them. Then again, from there itself, magnetism concept also comes in, that whether the given molecule is gonna be diamagnetic or paramagnetic. So once you will be able to form the molecular orbital diagram, it can also be asked, the magnetism can also be asked based upon VSEPR theory. So once you know how to fill the electron, then only you can answer this question. Then the next concept of bond length and bond order, this also comes from molecular orbital theory itself. Like if the electron goes in anti-bonding orbital, so you know that the bond order has a formula, that number of bonding electron and minus number of anti-bonding electrons and divided by 2, right? So you should know how many electrons are there in your bonding orbital and anti-bonding orbital. So for that, you should know how to make the bond this molecular orbital diagram. Then this concept of ionization energy, this basically is from your main group element. So the concept or the trend of ionization energy, how it changes from left to right, top to bottom, and there are various different trends also which I have not included. But yeah, there are certain groups which you have to study in detail. Like for example, in the boron group, you have to study about boranes and you have to study about boric acid, some reactions associated with it. Then when you go to the carbon group, you should study about silicanes and silicones. Then when you go to the nitrogen family, you should study about hypophosphoric acids and phosphoric acid and its derivatives. Then when you go to the oxygen family, then again similar type of like sulfur oxygen compounds are there. Then when you go to halogens, so there you have interhalogen compounds. So you have to study about them differently. That also is one part which I missed while making this slide, but yeah, you have to study that part also from the main group element. That is also somewhere, like that is also some topic from where you get question very frequently. Then you have acidity and basicity in the non-aqueous solvent. So that's also one of the concept from main group elements, where acidity and basicity things of in the non-aqueous solvents are being asked. So yeah, these are certain things, or these are certain concepts from main group and chemical bonding which you should never miss out. Okay, so few points which I said, which I verbally told you, which I have not included in the slide. I hope you will take care of them as well. Then next comes your F block element, or lanthanides and actinides. So in that, I have already discussed few points in the coordination chemistry, but yeah, one thing which is very important is electronic configuration. Most of the questions from F block element can be easily done if you know the electronic configuration correctly, if you know how to write the electronic configuration correctly. And That is first thing which you have to cover. Okay, so you have to first of all know the atomic numbers of the F block element. There is a trick to remember all the lanthanides and actinides. I hope you already do that. If not, please try to remember them. Please try to know the atomic number, and if you know the atomic number, it becomes easy to write down the electronic configuration. And then you have to know that which is the stable oxidation state. There are certain exceptions which I have written over here. So yeah, you have to cover the exceptions also. Like there are certain lanthanides which generally lanthanides give +3 oxidation state, but there are certain lanthanides which also give +2 oxidation state, and there are certain lanthanides like cerium which gives you oxidation state of +4. So yeah, you should be aware about those exceptions as well. Magnetic moment, as I said, is a very important topic from lanthanides and actinides. They can ask you spin only magnetic moment, they can ask you orbital contribution. Generally in lanthanides you have orbital contribution, and that's why you have that extended Landes formula for calculating magnetic moment. G value calculation is again an important thing. You should know the formula, and you should know how to implement that formula to solve or to find out the G value for a given ion. So all these things you can only do if you know the electronic configuration, if you know the atomic number. So the first point is very important, that whenever you start studying F block element, or whenever you have covered, or whenever if you are revising this topic, it's important to understand or remember the electronic configuration, so that you don't make mistake while doing these questions, which are super simple to solve. You will generally get them in 2 marker. Then color of the complexes or color of the ions. There are certain ions which are colored, there are certain ions which are colorless, there are certain ions which are colored in a particular oxidation state, so you should know about that also. I remember that once a question was asked from lanthanide, and it was super simple, but like there was like everybody got confused because of it was asked along with the transition metals or D block. So that's why there was a lot of confusion among the student, and that time many people did that question wrong. Okay, so yeah, you should be aware about at least these points from F block element, and it's very important to cover all the exceptions. I think I have covered this in the quick revision video of F block element. I'll give you all the important, like whatever videos I have made based upon these topics, all the links will be there in the description of this video, so you can click on those videos and watch them as a quick revision if you want to. Okay, next is inorganic spectroscopy. Now, this is something which people generally, when they prepare inorganic chemistry, they generally ignore, or they only study spectroscopy of organic compounds, or they study physical spectroscopy in more emphasized manner. But I would say that inorganic spectroscopy is also important. It also has a high weightage. So first thing is ESR or EPR spectroscopy, and in which you have to study about number of lines, like how many hyperfine lines, how many superfine lines you are going to get. Then there is a concept of G parallel and G perpendicular concept. So this is something which is related to your joint distortion of coordination chemistry, and that's where your tetragonal elongation, tetragonal compression, or square planar complexes are given, and you need to know how the G parallel and G perpendicular is gonna differentiate, or which will be greater than what, and also how this G parallel and G perpendicular is going to affect the number of lines in the given complex. So this is super important concept. Then there is a concept in which you study the number of carbonyl bands in the IR spectra. So this comes basically in the IR spectroscopy of inorganic complexes, where you have to predict the number of CO bands which you are going to get in the IR spectra. Now this topic basically is from your IR spectroscopy, and this is mostly based upon the symmetry of the complex. So depending upon what is the point group of the complex, whether it is C3V, C2V, D3H, what is the point group of the complex, that is going to make it easy to remember that how many carbonyl bands or how many different bands you are going to get. If you are following Ajay Kumar for organometallic compounds, then in metal carbonyl chapter you will get this particular table, where you will see that the point group is given and number of CO band is given. So it's very simple. You just have to look upon it once or twice, and you will remember that. And if a question comes from here, you will be like easily done with that. Next concept is of satellite peak. This question or this topic was first time asked. I remember it was in 2018 or 2019. Okay, so that was the year when this satellite peak concept was asked, and it was a whole chaos, because this was first time CSIR has asked such question. So there are certain there are certain compounds, or there are certain molecules, certain atoms which have like relative abundances are different. One of them is platinum. So these complexes have satellite peak along with them. This comes in NMR spectroscopy for inorganic complexes. So please study the idea behind satellite peak. It's very simple, it's not that difficult. You just have to read it once. If you have studied it, just revise it once. It's important. Then the last few topics from your inorganic chemistry are your term symbol. Now in term symbol you study the number of microstates, like how to find out the number of microstates. There are different types of questions that can be asked, and I have made a very good video on it a very long back, and that video still is one of the most watched videos of my channel, where I have discussed all the types of questions which can be asked from microstate. I will give you link again in the description of this video. You can watch that video on microstate. Then how to find out term symbol, atomic term symbol and molecular term symbol, that also have explained very easily in 15 to 20 minutes videos. So two different videos. Again, I will give you link of those videos in the description of this video. Also, I'll try to pin them up in the I button so that you don't miss out. So these three topics, term symbol, can be easily done with my videos. And once you are done with this topic, or once you have watched that video, I don't think that you have to even go to the books, because that video is super simple and enough to solve any question from term symbol. All right, so this topic is sorted, completely sorted. Then comes your bioinorganic chemistry. Again, this is one of the topic which is big, which is huge. And again, as I said, that there is the ratio of effort to weightage in the exam is not balanced over here. So you have to give a lot of effort to this topic, but the weightage of this topic is not that much. But what I have figured out in the previous few exams, that CSIR has now started increasing the weightage of bioinorganic topics. And for that, I have also made a video on my another channel where I have discussed that how research related to bio topics or bio related research is something which is coming in future, or which is right now in as one of the topic which is very much in demand in the research community. So that's why I think CSIR has also started asking questions from bioinorganic chemistry more. Do let me know what you guys think about it. Again, I will give you link to that video also in my description of this video, where I have discussed that how bio-related topics are having more futuristic demand. So that's all for this particular video. I just thought of discussing about all these things. Yeah, again, in bioinorganic chemistry, if you have not studied bioinorganic, or if you're planning to leave bioinorganic chemistry completely, I would suggest you to at least cover these topics. Hemoglobin, myoglobin is something, and the difference between them, there is one spectra of both of them, that also you should know what exactly makes difference between hemoglobin and myoglobin. What are the key points as the difference of both of them, that you should be aware about. Then hemerythrin and hemocyanin are also few of those like molecules, inorganic molecules, which are generally asked in your CSIR net exam. So you have to cover these topics. All right, so that's all for this video. I hope you guys liked it. Do let me know if you want video on physical chemistry and organic chemistry also. I'll be super happy to make those videos for you in the coming days, and I'll try to make it as fast as possible so that you have enough days to revise those concepts as well. So thank you so much for watching. Do subscribe to the channel if you have not subscribed it yet. Please like the video, that motivates me to make more videos for you. And that's it from my side. Take care. Bye bye. All the best for your exam. Keep preparing for it.